In this video, we're going to be looking at environmental factors that influence the rate of a chemical reaction, starting with temperature because it's probably the easiest to understand. Remember that temperature is simply a measurement of the average kinetic energy that reactant particles have, and only reactants with enough kinetic energy to form an activated complex, remember that that's what we call E-min, will be able to form said activated complex and then go on to become products. The conclusion of this, if we increase the average kinetic energy, which is the same thing as increasing temperature, because temperature is the average kinetic energy, we can increase the number of reactants with enough kinetic energy to form the activated complex, which can then go on to become products. The second variable that we can look into is concentration, which is simply a measurement of the number of particles that we have within a given reaction volume, which we can express with the formula moles per liter of volume. Therefore, if we add more reactant particles within the reaction volume, it is more likely that these reactant particles will undergo collisions with each other, because if there are more of them, it's more likely that they're going to hit each other, and as a consequence, the reaction rate with more particles is going to be higher than with fewer particles. Now, practically speaking, since concentration is simply moles per liter, there are actually two ways that we can increase the number of collisions based on concentration. And the first way, which is what we looked at already, is simply to add more reactant particles to the mix, which increases the number of moles of our solute, thereby increasing concentration. However, if we, for whatever reason, don't have more reactant particles to add, we can also decrease the solution volume or decrease the reaction volume. We call it reaction volume because concentration also applies to gases as well, where volume refers to the volume of the container rather than the volume of the solution. So in this case, if we decrease the amount of water, the amount of solvent that we have, without changing the number of particles, the particles exist in a smaller space and will therefore be more likely to collide with each other and therefore more likely to successfully react. The third variable that we're going to take a look at is surface area, which is simply the reaction surface of one reactant in which collisions take place. So what we can conclude from this is that increasing the exposed surface area of one or both of the reactants increases the number of possible collisions that can happen and therefore makes reactions more likely to happen as well. Now, practically speaking, there are two different ways that we can do this. Number one is what happens when we deal with solid reactants such as iodine pellets here. Now, if we look at the atomic structure of any solid, this can be a covalent solid like iodine pellets or an ionic solid like NaCl. If it's reacting with a gas, the gas particles can only collide with the solid particles that are on the surface of the solid like this. But if we take the solid and grind it up into a fine powder using a mortar and pestle, now suddenly the solid particles have been broken into smaller pieces, and previously unexposed atoms in the center of the solid mass can now be accessed by gas particles because it's been ground up. Now, what about surface area when it comes to liquids? So in this beaker and in this evaporating dish, we see the combustion reaction of ethanol. Now, we know that oxygen is required for every combustion reaction, and if we consider the oxygen outside of these containers, the oxygen can only come in contact with the ethanol on the surface of the liquid like this. So if we change the size of the actual container where the liquid is stored, thereby increasing the surface area of the liquid reactant exposed to gas, we can ensure that a greater percentage of the liquid reactant is exposed to the gas reactant. The oxygen in the atmosphere cannot access the ethanol underneath the surface, but if you put it in an evaporating dish that has a much larger surface area, you're taking more of the ethanol and spreading it out over a larger surface area so that more oxygen can come in contact with it, thereby increasing the rate of combustion. In the next video, we're going to be looking at two specific chemical reactants, or reagents rather, catalysts and inhibitors, and how they have a unique way of changing the rate of chemical reactions occurring.